Hi everyone, and welcome to the first mining department seminar of the year. To kind of introduce the seminar and introduce himself as a newcomer to the department, starting us off this year is going to be Dr. Steve Enders, the new mining department head. Dr. Enders has worked in the mining business since earning his bachelor's in geological engineering from mines in 1976. Later in his career, he earned his master's and PhD degrees from the University of Arizona. He ultimately went on to become the president of Phelps Dodge Exploration Corporation and then senior vice president of worldwide exploration for Newmont. He has more recently been the chairman, director, and COO of EMX Royalty Corporation, and he is a co-founder of Kubrick Canyon Capital Limited Liability Corporation. Dr. Enders has been at mines since 2009 as a research professor in mining engineering, department head for geology and geological engineering, and as the director of subsurface frontiers before coming back to mines as the department head for the mining engineering department. He is a Mines Distinguished Achievement Medalist and has just been elected to the Board of Governors for the CSM Foundation. Today, he will be talking about his vision, goals, and path forward for the department. So without further ado, Dr. Enders, please take it away.
Thank you, Claire, but I think you have to share the screen. Otherwise, I'll just be talking.
Oh, okay.
I think you just have to
moment.
say allow.
I think I just enabled it. Should be able now.
Did you? Okay, thanks.
Yes.
Oh, that's better. Yeah, thank you, everybody. Yeah, it's great to be back. Now that I finish, it's great. It's great to be back in the department. I was a research professor there from 2009 through 2016, really. And it's a delight to come back to the department, and particularly to be the first department seminar speaker for academic year 2020-2021. As you all have probably figured out, our department seminars this year are going to be, or at least this semester, are going to all be remote. That makes it in some ways less fun, but in other ways we can reach almost anyone in the world to come and give a talk. And so for all of you who are listening in and looking at this, participating in the seminar this afternoon, I would encourage you to think about who you might want to invite to give a talk at the seminar this fall. And if we have so many people that we can't fill them, then we'll think about filling next semester's roster of potential speakers. Just a little bit more, going forward, what I'd like to see is a much more impactful department seminar. And I've been working with the faculty and Claire and Mutu and Lucas on this, and trying to figure out a way to upscale our department seminars. Anyways, it's just one of a zillion different things I want to do when I'm department head. And so my talk today is really, it's built around what I talked about in June when I did a interview seminar for the department when they were interviewing department head candidates. And so for those of you who have seen this before, I apologize for giving it again, and maybe you'll find something different in my talk to think about. And for those of you who haven't seen it, I'm really glad that you're attending today. So I'm going to talk about, let me make it work. So I'm going to talk about sort of three key things today. I want to talk about my vision, and that's really about what I think the global imperatives are for the mining industry and for mining education. I'm going to take a look at the mining industry, where I think it's at today. We're going to dive into mining education and training in general, and then Colorado School of Mines specifically, and what the implications of those imperatives are that we see in those four different sort of scales of impact and influence. I have some content on what I think about the mining engineering department and where it goes. I'll give you a little snapshot on myself that doesn't relate to the things that Claire introduced me as. And then I've got a little bit on what my path forward is and a bit of a report already after being 1 month on the job. And before I move off of this slide, I really want to point out that this picture is an interesting picture. So what you see here is that you have a rowboat that's got a leak in it, and the people in the rowboat are really busy and totally focused on what is really urgent. And what you find in this photo is they're missing what's really important. And so I want to focus on what I think is important, not ignoring what's urgent, because if they don't bail out the boat, then they have a whole nother kind of problem coming their way. But I just want to set the scene that we have to focus on what's important more so than what's always urgent. And then we really have to identify those things that are both important and urgent, as this particular picture shows. So from a global imperatives perspective, I think we're going to see transformation ahead. This is a plot from Ray Kurzweil's work on the singularity is near from his book, and there's some other things that are shown in this plot. And really what this is a time chart from 2012 through 2050 and beyond, and it shows some really important things. The red lines are points in time where people have forecasted peak oil, right? So we're already in 2020. Are we at peak oil or not? I'm not sure, right? But it's going to happen. We've got peak gas coming in the next decade. I have a real hard time myself thinking that we're going to find peak uranium as a problem, because if we're really going to use that much uranium, we can generate plutonium in reactors. So I'm not sure that I particularly believe that part. But the other curves are some of the other important drivers in the world today. You can see the world population of 10 billion people by 2050. I think the numbers that I've seen is something closer to around 9 by 2040. That puts a lot of pressure on mineral resources, in addition to a lot of other things, energy in particular, and is an important driver going forward. The linkage with global warming and storm intensity, like we've seen in the last week with the hurricanes in Louisiana and Texas, reports of sea level rises and all this other things. The line mightn't be accurately plotted, but the trend is, right? And then you've got decline in rainforests and terrestrial ecosystems and the decline in fisheries. All these things are happening. And this concept that Ray Kurzweil puts out there, whether you really believe it or not, is what he calls this technological singularity. And I'll show that in the next slide what that means. But really, it relates to how much computing power we are developing. And I want to link that to this chart that says, this is also about energy use. And so when we talk about an energy transition, we're talking about a transition in terms of the mix of where we're getting it. But the fact is we're staring in the face of a huge demand increase in energy from all sources, and that will drive a lot of things, particularly mineral demand. So let's tease that singularity piece out a little bit. This is a chart directly from his book that starts in 1900 and goes through 2045, and you can see various technological things happening over time. You know, you start out with you know, the analytical engine in the early 1900s, and then you go to the first UNIVAC computer in the 1950s, the first Apple II, for those of you who are Apple users. These are now collector's items. The Power Mac came on. There's a few other things along this chart. It's leading to exponential growth in computing power. And you've all heard about the Moore law, right? This is not just creating exponential growth in computer power, it is creating exponential growth in energy demand, and we tend to forget about that, right? We tend to forget about it. The other thing that's really interesting here is this whole thing about accelerating pace of change. So it took 8,000 years from the agricultural revolution to get to the industrial revolution. 120 years to go from the Industrial Revolution to the light bulb. From the light bulb to the moon landing was 90 years. To get to the World Wide Web was only 22 years later, and the human genome was sequenced 9 years later. This accelerated pace of change is something that we see every day. And so the singularity piece here, and I relate that to energy use, is by sometime, some time ago, in the last decade, the computer power that we have surpassed the power of a mouse and of a brain, the brain of a mouse in 2015. The forecast is the computing power that we will have will surpass the brain power of a human within the next few years, 2023 on here. And whether you believe the timing or not, the concept is computing power, if it continues to accelerate at the same rate, our computer power will surpass the brain power equivalent of all that of human brains combined, which kind of blows your mind. I don't know if I buy all that, but I do buy the accelerated pace of change and the increase in energy demand. And that's kind of a new way of looking at things. So there's global imperatives, and there's some key themes here. And I've really only touched on this energy piece by looking at it in terms of this accelerated pace of change and computing power. Computing power relates directly to energy demand. But there's some key themes that have been out here for quite a while that relate to all of this, from what does it mean for mineral resources and mining and mineral education. So there's population increase, and the increase is not just about numbers of people. Most of the developing world wants more than they have. Whether they ever want to get to our level of consumption is different, but they have a demand for quality of life. That's a huge driver. There's climate change, there's global warming, there's carbon footprints as a function of the carbon-based energy world that we have today. Think about it in terms of energy transition. So going forward in the energy future, yes, we will be transitioning to renewables. We will, and alternative energy sources. They will compose or comprise a larger percent of the total energy supply that we have, but the demand for energy is going to be bigger. So will fossil fuels go away entirely? I'm not sure. Will coal go away entirely? No, because we use coal for other things in addition to its power generation. But the energy transition and our ability to sustain our world's economic engine and provide quality of life for all everyone who lives on this planet is something that directly impacts minerals. The other thing is leveraging the power of data. It's not just data and how we use it and how we understand it, but it's the fact that data requires power as well. So you can invert that line if you want. And then there's this concept of globalization and localization. We've seen a pullback on globalization as a result of the COVID epidemic or pandemic. We've seen more and more countries think about local things. Neither of those is going to go away, but it's going to be a tension. Okay. So there's implications for all of these drivers at a global scale. The first one is, no surprise, there's going to be an increased demand for mineral resources, and it's going to be very big and very pronounced. Those mineral resources are going to have to be extracted from the earth without a negative impact. And the expectation is the positive impact has to be shared more broadly than it has in the past. Those are huge implications for how we think about mining. Now, from a global, local thing, if you want to think that the United States is a local player in the global world, the US is currently energy independent. But given the geopolitical factors around supply chain with rare earth elements, other critical minerals, and critical elements and metals, there is a growing interest in getting the US to become mineral independent. Now, I'll tell you right now, as a geologist, that is not rational for all the materials that we need. But to a great extent, we can be much more mineral dependent than we have in the past. That's going to require mining engineers and other mining professionals to think differently about the business. And here's the other thing that seems pretty clear to me is mining will not become more simple. It will become ever more important and more complex. So let's think about the mining industry today and take a look at some of the drivers in the mining industry now that we've looked at global factors. So it's easy to see that there's a dearth of significant new discoveries of valuable mineral deposits, and the cost for doing so is getting exorbitantly higher every year. There are few new, robustly economic projects in the global development pipeline. Most of them are sub-economic and need something to make them better. They need a higher metal price. They need a social license. They need a permit from the government. They need new technology. There's all kinds of things that prevent projects that are good discoveries from being economic projects to be developed in the global pipeline, just the way it is. And our existing ore bodies that we have, they're all aging. And for all of you mining engineers who understand how you do mine planning, you know that there's naturally going to be declining grades as associated with those mine plans. The stripping ratios for open pit are going to get higher. The underground mines are going to get deeper, and the ores that we're going to be processed are going to be more refractory. The thing that's changed in the last 12 months is an awakening, and that's my word, an awakening that environmental, social, and governance issues are paramount importance. And what I mean by an awakening here is in the past, even as little as a year ago, the mining industry, and I'm making a generalization, but the mining industry in general gave environmental, social, and governance issues passionate lip service, right? Some did not even give it lip service. But these are now shown to be competitive advantages for the companies that have figured out how to do this. So now, not only does society demand it, but finally industry has figured out that if they get this right, they have a better company, a better mine, higher profitability, they're adding more value. These are big drivers. So I wanna also say that there's this thing called innovation and adoption of innovation. And I will assert, and I'm not the only one to assert, that miners are slow followers to adapt new technologies and new ways of business. So to give you an example, in the mining business, the pace of change, transformational change and innovation is about 3 per century. 3 per century. And I'm talking about things like in the last century, we had froth flotation at the beginning of the last century. We had open pit mining versus underground. We had heap leach technology come into place, both in gold and copper. Those are major transformational things that were different than just the incremental innovation that happens. But in the IT world, it's a pace of 1 per year. So it's really quite different. So you might want to ask why that is. And so there's a bunch of reasons for it, but I want to use the example of the Thomas Lawson, a 7-masted sailing ship that was built in 1902. And her 7 masts were the last ditch stand of the sailing ship industry to gain back market share against their foe. Their foe was the evil and burgeoning steamship freight transport industry. So what they were thinking is, let's just make it bigger. Just make it bigger. Let's add another mast and we'll beat them and transform it. But that didn't work out that way. The Thomas Lawson was so unwieldy and so top heavy that she foundered on the Sicily Islands off the coast of Cornwall on Friday, the 13th, go figure, in December 1907, and everyone was lost except for the skipper and the cook. So you can see a little bit why the Thomas Lawson reminds me a little bit like mining, is we actually have to find a different way of doing our business than by just making it bigger and better and adding another mast to our sail, so to speak. There's got to be a different way of thinking about it. So the implications here, I think, is that the mining industry must become an innovation leader, not an innovation lagger. And what I mean by that, it's not hard to find an innovation that's out there, and I've been involved in this, and you take it to mining companies, and the first 5 mining companies will tell you, I am not interested in adopting that technology unless 5 other companies have done it before me. And then it goes on, it goes on, it goes on, and it takes a brave company to do an innovation and prove that it works, and then everyone climbs on. But also I want to point out here that there's a new paradigm around the corner. There's a new paradigm for mining around the corner. And it potentially looks like this. Here's an announcement in May 25th, 2020, that Bill Gates and Richard Branson have put their sights on the mining sector. And they say that the investment opportunities for startups abound. And what they're doing is the tech giants are on the hunt for investment opportunities in the mining sector. And it's potentially a push that might change the landscape of the mineral resources industry forever. I can tell you, these are the steamboat people, right? These are the steamship companies. And the example is the mining business today thinks it just needs to add another mast to the Thomas Lawson as the way we've done mining. And what I mean by that is it makes you wonder whether the Freeports and the Newmonts are going to be the same leaders in the mining business in 20 years that they are today. So it's really quite different. And why are Bill Gates and Richard Branson thinking about doing this? It's about supply chain management and secure of supply and vertically integrating their companies. I don't know if this is going to happen or not, but they're already putting money into these things and they're already buying mining companies. So think about the implications then from the mining industry. You have to say that if the industry must become an innovation leader, which means we have to do things differently, and there's a new mining paradigm coming around the corner, then it says that traditional mining engineering education might not be prepared for this. So let's talk about mining education and training in the world today. So we're all proud that the Colorado School of Mines, and we as a Department of Mining Engineering take credit for a lot of that, is considered to be the top #1 mining and mineral school in the world. Okay, and you can see the others internationally here from the top 20. #2 was Curtin, #3 University of Queensland. Whether you believe that or not, that's the perception that is out there amongst our peers in the university. So I've been part of these surveys, and they ask other people, academics and department heads and people from all over the world, and they say, what do you think about, which of these schools do you know? And then of these ones that you know, tell me about their strength of their academic program. And there's this handful of 5 or 6 questions that you're asked about. And so this is a perception for us. And it's also an opportunity for us to leverage that perception today. But it shows you that mining education is a global and diverse, it's a global and diverse business. There's a lot of schools around the world doing it. And here's what I know, is that many companies are running their own training programs. They just need raw materials. And what I mean by raw materials, they need you as students, as graduates. We just start with that. And I'll go down in a few slides and I'll tell you how Freeport thinks about this. And you realize pretty soon that they don't necessarily need mining engineers. They need people with other attributes as well. So here's the world in the United States. Many of you saw the SME or the Mining Engineering magazine that came out, I think it was in June. There was a whole full-page article, Cheers to the Future of Mining. And what they mean by that is it's you, the graduates, or the graduates to be. It's congratulations. In this particular advertisement, if you will, or thank you, they listed 81 graduates from 32 schools. And what's interesting is most of those graduates were from the top 9 biggest US programs. And you can see who our colleagues are in this. Colleagues, I prefer to think of them as colleagues rather than competitors are in US mining education. It's mines, it's UNR, Virginia Tech, University of Arizona, South Dakota School of Mines and Technology, New Mexico Tech, Missouri Rolla, West Virginia, University of Utah. There are others, but those are the programs that we have in our cohort of mining educators in the United States. So there's some implications here. And when I tell you that they're not our competitors, they're our collaborators, as I believe that universities must work together and with industry to develop the next generation of mining professionals. We can't do it on our own. Doesn't make sense for us to do it on our own. We can do a lot of it and we can specialize in some things, but I think we can be stronger as a network of universities if we work together, and we can work with industry all together. And here's an example. So James Cook Mineral Resource Center and the James Cook or JKMRC and the JK Tech, they've both decided to integrate under one management structure. So you've got the University of Queensland having a Mineral Research Center, and now they have a Technology Transfer Center, and they're integrating their own program together. I'll tell you, the next one is one that we're working on here, is that the Colorado School of Mines this was in June, we had the Mines Newsroom report that the Colorado School of Mines and the Colorado State University and the University of Arizona are collaborating to develop a mines, tailings, and mined waste center of excellence. And we can be stronger together than we can apart. Just an example of what we're doing here along the lines of reaching out beyond what we do in our own world. So let's go on to mining education. Let's dive down into mining education. And I love this picture, right? I love this picture. This is what we think about miners in the past. So yesterday's miners, and industry's expectations was that miners, mining engineers, mining professionals had a strong background in mining, chemistry, and engineering. That's really what they wanted. The graduates were expected to have a knowledge of geology and mineral processing and how that impacts mining operations. They had to have an understanding of costs and profit. Mining engineers in particular were operations oriented. They were problem solvers, right? Problem solvers. But they were oftentimes rugged individuals, creative thinkers, and they were good observers. That's what was needed to be successful yesterday. Today, I would have to say that a lot of those things are still expected, but it's gone beyond that now. So today, it's expected that our graduates have a strong background in basic math, sciences, and engineering, in mining education, and having mining experience. So for those of you who have had internships, you understand the value of getting that experience as part of your education. We're expecting our graduates to be able to integrate geology and mineral processing with mine planning and operations, and all of that to understand the project economics and the mine economics. Oh, by the way, we're expecting you to understand the key principles of sustainability and environmental management. Oh, and by the way, you have to do that with good interpersonal and teamwork skills, and we're expecting you to be thinking critically. That's a lot, but it's not enough. Here's tomorrow. Tomorrow, you have to have a strong background, including computer science, computer and data science, And by the way, tomorrow is also today. So this is not really exactly tomorrow, right? Tomorrow's already here. We're expecting our graduates to have a blended skill sets in geology, mining, mineral processing, environmental and energy management, and I'm going to add to it business and management. Graduates are going to be expected to understand big data analytics, automation, and have integration expertise. And it's not just integrating it with the technology, it's integrating it with people as well. If you go back a slide, there was having to have an understanding of the key principles of sustainability. What we're saying now is there has to be an acute awareness of the environmental, social, and governance aspects of the industry. It's almost to the point where if you know how to design a mine ventilation system, but you can't understand how to get a permit to operate your mine, then you're in trouble. So you have to understand the permitting piece just to have an opportunity to be able to design mine ventilation or a haul road or a mine plan. Now, those are also required to be able to get a permit, but you understand that the social, environmental, governance, permitting part of this thing is just huge on the front end. And now we're expecting our graduates in the future to have a high emotional IQ, if you will, the same good interpersonal and teamwork skills, the same propensity for problem solving and critical thinking. And we're expecting you all to be continuous learners, to think system-wide rather than linearly. And we want you most of all to have leadership skills. It's just not enough to have the technical background anymore. So Leah Walker is currently manager of senior quality, is a senior quality leader for Freeport. I've known Leah since she was a geology intern working for me at Merritt, and she has gone on to become a Six Sigma expert and a senior quality leader working globally for Freeport. She spends a lot of her time with new recruits, early career engineers and professionals, right out of school to within 1 or 2 years. And what she says is, here's what we expect of the graduates. And she says 60% of them don't have it, and we have to teach it. So they're expecting their hires to have a knowledge of first principles. Just this is the basics of math and science and chemistry and physics and mining and geology and mineral processing. The first principles, you don't have to be an expert, but you have to understand all the first principles. They're expecting the graduates that they hire to have leadership and management and execution skills. And what I mean by this is you have to have an ability to get stuff done. They're looking for efficient communication skills, and that is not texting. That's not necessarily emails. That's verbal communication, oral communication in a formal setting. What Leah told me, she says, is most of the people that she teaches in Freeport can't have a competent conversation with their boss, much less their boss's boss, about their project. And that's scary. The person has to have change management skills, because I can tell you what you work on at the beginning of your career is going to be entirely different than what you work on 10 years later or 20 years later or even more. It might be a different project next year, and you'll have to figure out how to change to make that work. The problem solving skills that she highlights are these 5, which are really interesting. It's hypothesis-based thinking. It's the ability to use analytics to diagnose problems. It's being able to understand root cause analysis to figure out what really needs to be changed from a fundamental solution perspective. It's systems thinking rather than linear thinking. So I'll give you an example. Linear thinking is how many dipper buckets does it take to, with a certain fixed size of your dipper bucket, to fill a haul truck, right? Of fixed capacity. Well, the answer is like 3 or 4. There's a number there, it's linear. But a systems thinking problem is one around how do you keep a community happy? There's no one answer to that. There's just no one answer. So it's a different way of thinking. And then agile design principles, which is an engineering concept. And then she says the quantitative analysis skills that we want is engineers have to understand analytics and statistics, and not just geostatistics, but statistics. They have to understand data shaping, and here we go back to the computer science piece. We're expecting them to know Python coding. That's a lot. That is just a lot. So what are the implications? The implications is that universities have to work together, and they have to work with industry to develop the next generation of mining professionals. Without knowing what Leah Walker and Freeport expect of graduates, we don't have a very good concept of what we need to do to get our students the background and experience to be able to fit the bulk of the requirements that they have. And what it says is not all of them will be engineers. Not all of them will be engineers. So an engineering background is going to be necessary, but it won't be sufficient to ensure success. What's going to be necessary is, in addition to that, is the emotional intelligence, leadership skills, understanding business and economics, and all of that within the mining context, not necessarily business and economics from a macroeconomics around the world, but how does that work in a mining operations or mining company context. The other thing that I want to point out here is that research, this is my view, research needs to be focused on topics of fundamental relevance. And I've got no objections to fundamental scientific research because that can make major breakthroughs in applied science and applied engineering applications. But in general, the research has to be of fundamental relevance. Fundamental relevance to, like, your neighbor, the readers of the Denver Post, your family, the people in your community. Is why are you doing that research? It has to have fundamental relevance. Oftentimes research is done because it can be done, because I have a lab that allows me to do that kind of work. That may not lead to research that has fundamental relevance. It might, but it doesn't. And I also think then there has to be a new research funding paradigm to make all this work. I'll give you an example of investments in fundamental scientific research and having breakthroughs in applied science and engineering. So Bell Labs hired the top 100 best, most qualified graduates every year while they ran Bell Labs over about a 20-year period. And they were given the mandate to research anything that they found of interest, so as long as it related in some ways to their business. And it turns out that Bell Labs, out of doing all of that fundamental research, ended up with more Nobel Prize winners for their discoveries, and what was ultimately applied in terms of communications technology that we have today was as a result of doing that. So fundamental scientific research is just as important, but there has to be something that's relevant to society, not just more results from a lab that can be published. My opinion. People may disagree. Okay, we all know about Colorado School of Mines, so I'll just talk about that for a minute. We have a lot of capabilities in and around this whole mining piece, right? We have mining, we have renewable energy, we have water and environmental work, we have extractive metallurgy and processing, we have material science, we have geoscience and engineering, we have underground construction and tunneling, I will add. There's a lot here. We have 300 academic faculty, 16 academic departments, and our distinctive focus is on earth, energy, and the environment. This is an awesome place to be involved in mining engineering and education and training and research around mining and mineral-related themes. There's initiatives at the Colorado School of Mines I've been involved in a lot of these. So some of you may have heard Mines at 150 initiatives. So I happen to have been a student when Mines was 100. It's nice to be back and being engaged as I am as department head. And Mines at 150 is this initiative we have to kind of reimagine our future, and it's tied to not just fundraising, but to programmatic things. And there's two initiatives that President Johnson has already established. One is around materials and advanced manufacturing, and the other one is around earth and space exploration, technology, and engineering in sort of a broad way. The Subsurface Frontiers initiatives are part of the Earth and Space Exploration, Technology, and Engineering initiative. And I happen to be the director of Subsurface Frontiers for the university. It's a role that I kept in addition to my department head role. And there's 5 major areas that we are working on. One of those is renewing and improving our urban infrastructure. Think about smart cities, think about suburban infrastructure. It relates to underground construction and tunneling, and there are a lot of interesting things here. The next one is sustainable exploration and development and production of tight oil and gas, tied closely from a fossil fuel, petroleum, oil and gas production, carbon sequestration, what's the right word? Climate smart stuff is CO2 capture, utilization, and sequestration. There's an initiative in the frontiers to provide access to clean and fresh water. And then there's this big bucket of what do we do around sustainable mineral resources. And I don't know if any of you saw today, but the EPA just announced that it's going to be opening up a brand new office in Colorado Springs called the Office of Mountains, Deserts, and Plains. And that announcement mentioned their focus on prioritizing and accelerating the cleanup of abandoned mines in the Western US. And I just want to applaud that, because that has been an environmental albatross around the mining industry's neck for decades. And it's about time the EPA has stepped up to this. We also have something going on now. It's in its early stages. It's been known under a couple different names. It's the Climate Smart Mining Initiatives, or the Essential Minerals Center. And that is where universities, in our case, mines, wants to partner with industry to develop the next generation of mining professionals, but to do that within the context of understanding the importance of minerals, right? Minerals, and of course, mines and mineral resources in the future. And it ties back to what these big global drivers are. And there's a couple of other initiatives going on campus that I'm involved in. Is the EMI and the Geology, Geophysics, Petroleum Engineering's core lab are looking at combining and building out a much bigger facility called the Subsurface Discovery Lab, and there'll be a lot more coming on that as we move that forward. And then I've been involved in an exercise called Reimagineering Mines at 150, and their fund shops. And that is something that, should we decide to move forward on that, would be something we would do in spring 2021. But it's about reimagining what mines could be beyond its 150th anniversary. So these are some interesting things that are going on at our school. I'm not going to dive into the details on this, but you can see that the Earth Resources and Environmental Programs have some strategic priorities in the upper left-hand corner. There's some interesting, there's a nexus for innovation around Earth, energy, and the environment with the Subsurface Frontiers initiatives I talked about. And I guess one way to think about this is, imagine a subsurface Google Earth that's just as good as a surface Google Earth, where you can go down below the surface and see data and models at different scales, and to be able to update those scales in real time, and actually have a 4D Earth, if you will, long-term, big, hairy vision, but something that might be possible out of that initiative. There's always this concept of wanting more diverse students, having a more inclusive and access university and department. And then there's initiatives around alternative sources of revenue, and some of that is in our department, particularly around our professional master's programs and some of the international projects that we're involved in. So we have a new normal, right? The new normal is COVID-19 and all the changes that we've seen as a result of everything that was put in place from the end of March through the beginning of school this year. And so that changes a lot of things for us, and we don't know where that's going to go, but I applaud everybody for, you know, wearing your mask, maintaining social distances, following the guidelines for living a safe and healthy life at the university these days, but it does change things, and I didn't want to ignore that. So I want to dive into the mining engineering department a bit and wrap up with my view of the department and my objectives and goals for it. I'll talk about the vision, which is here. And really that is that the mining engineering department wants to be, or is to be, recognized internationally as the world's premier center for education and applied research in the diverse fields of mining. I would say mineral processing and extractive metallurgy now, underground construction and tunneling, and a number of other things that we know we can do in our department. Mine health and safety is another. So the short list is a bit short right now. there's more that we can do to fill out that vision. This is a vision that I think to some extent we've achieved, and it's time to move to a broader, bigger vision. I'll talk about the strengths, weaknesses, and opportunities, talk about big issues, drivers, and goals and objectives. So when I think about the department, I think we have some wonderful strengths. First of all is our reputation. Second of all, and not in any priority, is our graduates and our alumni, and I would add students. And I would add, well, I already have it there, faculty, staff, and students. We have great industry relationships. We have a great curriculum and a new online professional master's program. We have outstanding facilities like the Edgar Mine and the EMI and the rest of our labs that we have access to. And we have great connections. The weaknesses is we have a small undergraduate student enrollment, and research funding is just never enough. My view of opportunities is it's time to take advantage of the new mining paradigm. And I don't mean just the new mining business paradigm where you got Bill Gates and Richard Branson out there doing something maybe, but I'm talking about the drivers that are headed our way. I tell you what, I want to be swimming downstream. And here's an opportunity for us all to swim downstream and make some pretty big things happen. So that's the ability to use the global and national situations to help drive change. And honestly, it's time that we change the face of mining. The face of mining has to be different, because we all know that it's just not old white guys like me that are in the mining industry these days. It's a different face of mining that's out there, and they're doing some tremendous things. And you all as students who are going to go into the mining industry are going to be that new face. And I think it's so exciting. There's some threats. The budget impacts related to the COVID-19 stressors are real for us. They're real. They're affecting our department and everyone else across campus. And then what I think is a threat is, I think, based on an assessment we did over the summer of students and of faculty, I think we have some improvement that we can do in terms of our department climate and its environment to make this a better place for all of us to work and a more attractive place for us to bring in students. Some top of the mind issues that I think not just our mining department has, but all mining departments have. First is low undergraduate enrollment, which I've already talked about. Second is the ability for us to keep up with technology and research. That's why we have to partner with industry. Some of the most cutting edge research is coming from industry, and not necessarily from the mining companies, but from the service providers and the engineering and consulting companies. They are driving research. It's keeping ABET up to date with what we want to do going forward, which is a mining engineering, mining professional program that relates to the future, not to the past. And then some way we have to be able to increase research funding, and that's a problem. That's a challenge. So the drivers, right? The drivers for the mining engineering department are US mineral dependence and critical minerals, the energy transition and adaptation to global warming, the ESG revolution, the tailings and mine waste crisis, augmented AI, right? Artificial intelligence, machine learning, augmented reality, virtual reality, automation, data analytics, a lot of the things that Shebna works on. There's this demographics of an aging talent pool. I am one of them, by the way. There's a new mining business paradigm out there, and there's COVID-19s. There is nothing cooler than to have all these things happening at the same time for us. Our challenge is how do we manage through it? So my goals for the department are to enhance our reputation as the #1 mining school, right? Enhance our reputation, let's build from that. I want us to take the lead in changing the face of mining. That is you as students and as graduates. It's the faculty that we hire. I want us to find our voice on relevant topics as it relates to the mineral resource industry and world. And these three things can be captured into what I call my 3 R's. Restoring our reputation with our alumni and industry partners, recruiting into our undergraduate program. My view is I'd like to see the average number of undergraduate students be doubled within the next 3 years. And I'd love to see that happen mostly through the recruitment of women if we can. Women and other disadvantaged students may or may not be possible, but I want to see us do that. It's a game changer when we have more undergraduates in our program. And rebranding is not just about having a voice on relevant topics. Like I had to give a quote today, and so did Linda Figueroa, and so did President Johnson, to the EPA, so that there was some support they had for their announcement. And that's a bit about us having a voice and using it. But rebranding is recognizing that we're not just mining engineers. We have research into regolith on the moon, into drilling on the moon. We're thinking very hard about introducing a space mining undergraduate mining program on one end of the department. On the other end, if you want to think about it, with the inclusion of our colleagues in extractive metallurgy and mineral processing, we have a really thriving industrial recycling program in our department. And then in between, we have traditional mining education, we have sustainability, we have mine environmental stuff, we have health and safety, we have the work that Shebnam's doing in terms of AI and AR and VR and all. There's so many facets to our department that by calling ourselves mining engineers, I think we're being a bit too narrow. Okay, that's my view on the department. So recruiting, restoring recruiting and rebranding are my three key themes. So as a department head, what I want to do is I want to be the leader who helps make this happen. I want to bring cohesion and develop a shared vision in the department. I want to manage excellently and treat people fairly. I want to listen. I want to be decisive. I want to get stuff done. And personally, I'm an alum of our university, and I want to give back, and I want to pay it forward, and I want to be able to make a difference. That's what I want to do. That's what drives me as a department head. For me personally, right, I want to hike and bike the entire Colorado Trail over the next 3 years while I'm still department head. I want to do that, right? I want to be able to spend time with my family and my friends. I want to be able to coach and mentor my grandchildren. And yes, I do want to retire someday because it will be time for someone else to take over. And I just want to let you know that it's not just about the department and not just about the Colorado School of Mines. My life is also about me as a person. So I want to wrap up and tell you the path forward has been to talk with and listen to everyone. So far, since I've been department head, I guess I started a week early, I've done 35 interviews between an hour and a half and 2 hours with faculty, staff, and as many people as I can, including some of you grad students. And I have more interviews to set up. I've already completed an assessment of the program, which is some of the report out that I have today and other things I'm working with on the faculty. I've held 2 workshops already. One was to do a leadership assimilation of me as a new department head for faculty and staff. We've completed half a day of a 4-day workshop in social styles and versatility. That's about our preferences for how we communicate and deal with each other, interact with each other. And I'm in the process of conducting a situational assessment, which is a dive into the budget and the operational plan and the finances of the department, looking at our department objectives, all with a view of pulling all of this together, particularly the information I get from my interviews, and update my SWOT analysis. I want to align our strategic plan. And in the end, we're going to develop together SMART goals and objectives. And we're going to have 3 W's. And what I mean by that is if we're going to get stuff done, if we're going to GSD, we're going to want to know who's going to do what by when. And lastly, there's a couple of things that I want to put an emphasis on here is I really want to work hard on our industry and alumni relations. They are key stakeholders for us. And recruiting is another big initiative that I want to put some major effort in. And of course, we already have a diversity, inclusion, and access committee or team in place and working towards that now. So I think that's the last I have. I will stop sharing, and I will turn that over for questions if there are any. Thank you for listening.
Thank you. I don't have a question, but I enjoyed listening to your seminar, Professor, Okay. Thank you.
You're welcome. Thank you.
Can you hear me? Jerry Martinez.
Yeah, I can hear you.
All right.
Thank you, Jerry.
Okay.
I would just say one thing is one of the best parts about doing a seminar talk or a lecture remotely is the tomatoes that would get normally thrown are just going to land on your own computer and not on me. So.
I don't think this was such an occasion. Okay, thank you.
Thank you.
And Dr. Enders, I don't have a question either, but I just wanted to thank you so much for agreeing to do this seminar. It was really refreshing to hear everything that you have planned for the department and everything that you think is going to happen with the mining industry that you've observed happening so far. I am going to read a question that it looks like we've got from the chat from Sarah Hastings Simon, and then I actually have to run to my next meeting. So one moment. Hastings Simon requests that you say a little about how you see mining working with other departments on campus, in particular to achieve the goals which you laid out for the department.
Sure. I mean, I'll just use the example of this tailings, the Mine Tailings and Waste Center that Priscilla's been championing. And we've got a memorandum of understanding with CSU and U of A now. I mean, that's a great example is all three universities have capabilities and capacities, but when we work together, we can do far more than any one of us can do individually. And that's just a matter of finding people we want to collaborate with, finding that there's energy enthusiasm for a program like a tailings center, and then deciding how we want to work together. I mean, that's just a great example. And I think the mental shift that has to happen is the other universities are collaborators, not competitors. So here's a way to think about it. When you have a gas station on one corner of an intersection and the next corner ends up being a gas station, you would think they would take customers from the first gas station, and what ends up happening is there are more customers for everybody. It's the same way for us in our mining engineering programs around the US in particular, is when we build stronger programs, we can attract more students to our programs overall. And I think that benefits us. But that's an example.
So, Dr. Enders, I have a question.
Sure.
Solomon.
Yes,
Yeah. What I've seen is that our undergraduate students don't normally continue with their masters and PhDs here at the mining engineering department and even the school. Those who even continue in the school, they go to other departments like mineral economics. Have you realized that, and have you figured out the root cause and how you are going to address that problem?
So thank you for that question, Solomon. I guess I'm not convinced that it's actually a problem. It is a valid observation, right? It's a valid observation. But the paradigm, the paradigm in the mining business today, worldwide, is that a bachelor's degree in mining, engineering, or related field is a terminal degree and all that's required to work professionally in the business. That's the paradigm. I think that there's great opportunity for students to get a master's or a PhD in mining engineering or the related fields. A master is a great way for someone to upskill in a particular focus area, okay? Pardon my clock. A PhD though is for someone who wants to embark predominantly on a research career, really, I think, or a teaching career. It makes sense to me. Not everyone wants to do that. I think it makes total sense for mining professionals, particularly mining engineers, at some point in their career to branch out and get a degree in business or finance, because we don't have that many people doing proper traditional formal mining engineering in mines, but we have a lot of mining engineers in management and leadership positions, and that requires different skill sets. So, and I guess the other thing, Solomon, you're a perfect example of someone coming in from another country who wants to come in and get a graduate degree at a school like the School of Mines, you can't get that locally. And you get a lot of other things from your graduate program than just the content that you did in the dissertation research that you've conducted. So I think there's a huge value proposition for a strong international program in our undergraduate as well as our graduate program at Mines.
What about the flip? I'm sorry, did I interrupt someone?
No, perfect timing.
All right. What about the flip side of that? Someone who is in a different field, but thinking of interfacing with the mining industry. What programs in the mining engineering department of the Colorado School of Mines do we have to do that sort of thing?
Well, we already have a program in our department. It's called correct me if I get it wrong, but it's the Earth Resources Engineering Program. Isn't it what it's called?
That's exactly right. I'm Jim Moraga. I'm actually in there, and I come from computer science, and I have an MBA. So yes, we have something here, and it's working quite well.
Yeah, it's really interesting. It's really interesting. So that's a great question, and Jim, thank you for bringing that up. But this is what I say about rebranding, if you will. I am so proud of our program. It is really big, and it deserves to have a worldwide reputation. But our worldwide reputation, I don't think, is built on an awareness that we offer so much to so many people. It's built on a different part of the perception of our program. But we've got a great program that Jim's involved in that anyone from outside can attend. So yeah, that's exactly right.
Steve, Steve, this is Corby. If I may make a comment, you said that Leah Walker worked with you or for you at some point. I'd like to have an audience with her someday. Freeport has been a very strong supporter of the mining industry in the United States, Colorado School of Mines. But I think part of the situation that higher education in mineral engineering finds itself is the general disconnect between industry and academia. And the point is this. Leah, you put up a slide and Leah says the industry has very high expectations. We need this, we need that, we want this. That's fine. The realities of academics, as you well know, are that we have stresses and strains financially. Credit limitations credit requirements are going down. And then quite frankly, I'm appalled, and I'm a supporter of Freeport. They've been good to me. I'm appalled when you have high prices of silver, high prices of gold, relatively good prices of copper and molybdenum, and all of the young people who had internships or were freshly recruited by Freeport were laid off. And so it's fine to have high expectations, but there has to be some give and take. So, I would like to have a discourse with her and talk to her about the realities of academics and the realities of moving forward in this business and creating, mentoring, and develop new talent.
Yeah, so I've invited her to give a seminar talk.
Love to meet her.
Okay.
Nevada Gold Mines, where my son works, did not do that.
Yeah, so I know both Newmont and Freeport really well, and it turns out that we dislike the things we know the most.
No. Freeport's been good to us.
No, I get it, but it's easy to point our fingers at them, and so I have my own issues with those companies and how they operate. But nonetheless, she's an invited speaker for the Southwest SME mining Southwest SME meeting. I think it's in October, and she's coming up. But I'd like to have her come and give a seminar talk on well, she doesn't have to come here, she can deliver it remotely, but on exactly that topic. And it's a great opportunity then for us to have this kind of conversation. So that's what I want to do about that, Corby.
Right. Okay. Thanks.
Yeah. Great question. Other questions from people? These are great questions.
Okay. I have a question, Professor.
Yep.
Okay. Firstly, I need to appreciate for your great commitment for this webinar. Even I am eager to attend this one. I am Yohalashit from Africa, Ethiopia, in the Department of Mining Engineering. Today, I learned a lot of things from you at the new HAD in Colorado School of Mines. My question is, Professor, we are at the new beginning to develop the mining system in Africa, especially in Ethiopia. So a new HOD, do you have a plan to collaborate with us in different projects, different work experience sharings? So we are interested to share with Colorado School of Mines with your department as well. So what is your plan, sir?
So you say you're from Ethiopia, right?
Yeah.
Yeah, so we currently have an initiative with a university in Ethiopia and a proposal into them to work with them. So in Ethiopia, the answer is specifically yes. We have a proposal already submitted to a university over there. If Priscilla is still on, she might be able to, or Jamal might be able to comment more about that than I can. But
I believe
that's one of the things.
at the moment, I think it's more with the government agencies
Oh, okay.
that oversee mining, but it only makes sense if we extend this to engage universities as well.
Yeah, okay.
The proposal we put in was for the U.S. State Department in
Okay, thank you.
collaboration with the Ministry of Mines.
Yeah. So you guys have to remember, or you all have to remember that I've been in the job exactly a day and a month, or a month and a day now. And even though I've done 35 of these things, there's still a lot for me to learn as a new department head. So I appreciate everyone stepping in and filling in what I don't have a grasp of yet. Other questions from the audience? This is great. We had 50 people attend. I think that's outstanding.
Thank you once again. Thank you.
Yeah, looks like that was it. Awesome. Thank you, Steve. It was really informative. I think Claire had to leave already, so
yeah,
she won't be able to make the nice outro, like the intro, but thanks again. Thanks everyone for joining us. And please make sure to sign up for email news over our website.